Have you ever watched a stream run past you and wondered what it would actually take to drink from it safely? Not the crystal waterfall you see in movies, but the real water, the brown, slow-moving kind that smells like mud and old leaves and something you cannot quite name. Your last clean bottle ran dry hours ago. Your throat is raw, your head is starting to ache, and every sip of the wrong water could put you flat on your back for days. Here is the uncomfortable truth about survival situations. Most people do not die of thirst. They die of bad decisions made while thirsty, and the only thing standing between you and that mistake is a choice you have to make about water. You can see but cannot trust. Now here is what almost nobody tells you. 2 small strips of metal, 1 copper, 1 zinc. You twist them together, drop them into that filthy water, and walk away. 8 hours later, that same water is cleaner than what comes out of most city faucets. No filter cartridge, no electricity, no boiling, no chemicals. Just 2 metals touching, doing what the earth designed them to do, long before humans had words for it. Let that sit with you for a second, because the rest of this video is just the evidence for that one impossible-sounding sentence. And here's a challenge for you before we go any further. If that idea made you pause, even for a second, smash the like button right now. Because this is exactly the kind of knowledge that gets buried behind paywalls and marketing budgets everywhere else. Subscribe if you want to be the person who knows things other people do not, and share this with one person you would trust with your life in an emergency. Do it now while the thought is fresh. Because this video is not going anywhere, but your attention might. This is not a survival hack someone invented on the internet last week. Ancient Egyptian healers used this principle about 4,000 years ago to treat battlefield wounds. Greek sailors used it to survive months at sea without dying of their own drinking water. The Aztecs, on the other side of the planet, with zero contact with Europe, discovered the exact same thing on their own. And in the 1960s, when NASA had to keep Apollo astronauts alive in a tiny capsule, flying through the vacuum of space, their engineers built a device around this same forgotten chemistry. So let me ask you the question that started this whole investigation. If 2 pieces of scrap metal can purify water this effectively, why does the global water filter industry make around $35 billion a year selling you plastic cartridges that expire every couple of months? That is the mystery we are going to unpack today. Not conspiracies, chemistry, history, and a little bit of honest economics. By the end of this video, you will know exactly how to build this system yourself, what it can do, what it cannot do, and why the people who sell you clean water have very little interest in you knowing any of it. Close your eyes for a second. Picture the banks of the Nile River around 2,400 years before the Common Era. The air is thick with dust and the smell of blood. An Egyptian field healer crouches beside a wounded soldier. A spear gash runs across the soldier's thigh, deep enough that bone shows through. In this era, the wound itself is rarely what kills you. Infection is the real enemy, and infection begins with water. The healer reaches for a vessel, not clay, not wood. Hammered copper, beaten thin and shaped by hand. He fills it with river water and sets it aside. He does not boil it, he does not add herbs, he just waits. By morning something has changed, the water is clearer. It carries a faint metallic crispness. The healer has seen this transformation hundreds of times, because his father showed him and his father's father showed him a chain of observation stretching back longer than any written record. He does not know why it works. He only knows that soldiers whose wounds are bathed in copper-treated water survive, and those treated with plain river water too often do not. In his world, that difference is the difference between life and death, and he has built his whole practice around it. This was not guesswork. One of the oldest surviving medical documents in human history specifically describes copper as a sterilization tool for both drinking water and wound treatment. When you read lines like that, you understand that the ancients were not superstitious children. They were observers. They ran the same experiment for generations, and they trusted the results even when the mechanism was invisible to them. That is not primitive thinking. That is science without a microscope, and it is more rigorous than most of what passes for knowledge today. But Egypt was only the beginning. Around 400 years before the Common Era, Hippocrates, the man we still call the father of modern medicine, documented copper compounds as treatment for open wounds and lung disease. The Greeks pushed this further than anyone expected. Their sailors faced a terrifying problem. Water stored in wooden barrels turned green and rotten within days at sea. Entire crews died of dysentery, not from enemy ships, but from their own water supply. Yet water stored in copper vessels stayed drinkable for weeks, even months, under the brutal Mediterranean sun. The Greeks had no concept of bacteria, no microscopes, no chemistry, but they observed a pattern that was impossible to ignore. Copper water meant survival. Wooden barrel water meant death. So they built their ships around that observation, and their sailors came home. That single practice spread across the entire Mediterranean trade network like a rumor that refused to die because it worked. And in the ancient world, what worked was law. The Romans scaled this insight into infrastructure. Their engineers ran copper pipes through aqueduct systems, delivering noticeably safer water to public baths and homes across the empire. Roman legions carried copper vessels across Europe and North Africa, not as luxury items, but as standard military equipment, packed alongside shields and spears. They understood, even without the science, that this metal prevented the waterborne diseases that historically killed more soldiers than swords ever did. History books love to talk about Roman engineering genius, but the quietest piece of that genius was a metal pot. And the practice did not stop at the borders of these empires. It traveled along trade routes the way languages and recipes do, carried inside the packs of merchants who had no idea they were transporting a water treatment system. Every time a copper cup crossed a border, an experiment crossed with it. That is how knowledge moved in the ancient world. Not through journals, but through objects, through habits, through the simple refusal of certain ships' crews to keep dying. Now here is where the story takes an extraordinary turn. Thousands of miles away, across the Atlantic, the Aztec civilization had absolutely no contact with the Mediterranean world. Different continent, different language, different gods. Yet Aztec healers independently discovered the same phenomenon. They used copper-infused water as a gargle for throat infections and built it into their purification rituals. On the other side of the world, in India, the Ayurvedic tradition prescribed storing water in copper in brass vessels, a practice called tamra jal, which may date back more than 3,000 years. And this is not ancient history. It is practiced right now, today, in millions of Indian households, passed from grandmother to mother to daughter. 5 civilizations, 4 continents, thousands of years apart, all arriving at the same conclusion. That is not coincidence, that is chemistry, fundamental, universal. Chemistry, waiting patiently for humans to notice it. And if you really sit with that, it is one of the most humbling facts about our species. The same truth kept being discovered, forgotten, and rediscovered, because each generation assumed it was the first to think of it. So here's a small favor I want to ask you, right in the middle of this story, because the next part is where things get wild. Before we move on, take 5 seconds and type the word Earth in the comments. Just that one word. Why? Because people who watch this far into a video are rare, and I want to see you in the comment section. You will also prove something to yourself, that you are not just passively scrolling. That tiny action changes how you watch the rest of this video, I promise. And while you're down there, hit the subscribe button so the algorithm knows you care about topics like this. One word, 5 seconds. Go. So how do we lose this knowledge? That is the uncomfortable part of the story. For millennia, this was common knowledge. Copper vessels were standard in kitchens, hospitals, and ships around the world, so ordinary that nobody wrote books about it. Then came the Industrial Revolution. Copper was expensive, plastic was cheap, chemical chlorine could treat water at industrial scale, fast, uniform, and easily measured. The old ways were abandoned, not because they failed, but because mass production demanded uniformity and low cost. Copper pots became plastic bottles. Natural purification became chemical processing. And an ancient understanding quietly slipped out of collective memory. We did not lose it all at once. We lost it one convenient choice at a time. It resurfaced by accident. In 1984, a researcher named Don Hesketh was running routine water treatment experiments. At some point during his work, he dipped a brass pen into a beaker of heavily chlorinated water. Brass, in case you're not familiar, is an alloy of copper and zinc. What happened next stopped him cold. As the pen contacted the water, the chlorine simply vanished. No chemicals added, no electricity applied. The physical contact between the copper-zinc alloy and the chlorinated water triggered an instantaneous reaction that neutralized the chlorine completely. The kind of discovery that makes a scientist cancel his evening plans. Hesketh spent the next 3 years studying and refining this reaction, testing the limits of what it could and could not do. He patented the technology under the name KDF, which stands for kinetic degradation fluxion, and licensed it to filter manufacturers. And if you look at the water filter industry today, you will find KDF media quietly sitting inside some commercial products, almost always as a minor supplementary component, never as the main event. Keep that detail in your mind, it matters later. But to understand why this discovery matters and why the industry keeps it at arm's length, we need to look at what actually happens at the molecular level. And I promise you, this part is simpler than it sounds. No chemistry degree required. And when copper and zinc are placed together in water, they form something called a galvanic cell, named after the Italian scientist Luigi Galvani. Think of it as a tiny self-powered battery. Here is what happens, step by step. Zinc is a restless metal at the atomic level. It desperately wants to give away its electrons. Copper is the opposite. stable, receptive, willing to accept what zinc offers. When these two metals physically touch while submerged in water, zinc atoms begin releasing electrons spontaneously. Those electrons flow from the zinc into the copper. The water between them acts as the bridge that completes the circuit. The result is a tiny, persistent electrical current. You will never feel it. You could not power a flashlight with it. But at the molecular scale, it is a weapon. Imagine a battery so small that it powers nothing you can see, yet runs constant security patrols against everything you cannot. That is what is happening inside that container of water. Here is another way to picture it. Hold a copper wire in one hand and a zinc nail in the other and touch them together inside a glass of water. You have just built a tiny battery with no wires, no casing, and no label. The water is doing the job of the battery acid. The metals are doing the job of the electrodes. And the current they produce, faint as it is, spends its entire life attacking the things that would make you sick. Not occasionally, not when it feels like it. Constantly, for as long as the metals keep touching. This current does three things simultaneously. First, it eliminates chlorine. The electrical reaction forces electrons onto molecules of free chlorine, changing their chemical structure. Toxic chlorine becomes harmless chloride, the same compound found naturally in table salt. The water stops smelling like a swimming pool and starts tasting like rain. This happens in seconds, not hours. Let that sink in. Seconds. Second, it captures heavy metals, lead, mercury, arsenic, hexavalent chromium. These dissolved poisons are drawn into the electrical field, generated by the galvanic reaction through a process called electroplating. They are pulled out of the water and permanently bonded to the metal surface, trapped, locked in place. You rinse the metal later, and you're literally rinsing away heavy metals that would have ended up in your blood. Third, it destroys bacteria. This is the mechanism that kept Egyptian soldiers alive and Greek sailors healthy. The galvanic current disrupts the internal enzyme processes that bacteria need to function and reproduce. On top of that, the reaction generates reactive oxygen species, essentially tiny molecular grenades that tear through bacterial cell walls. The water becomes a hostile environment where bacteria, algae, and fungi simply cannot survive. Given enough contact time, studies and manufacturers report reductions of over 99% for many common waterborne bacteria. That is not a marketing number. That is the difference between a bad week and no week at all. This is not magic. This is electrochemistry. It is the same principle that powers the battery in your phone, except here the battery is two metals, the circuit is dirty water, and the output is purification. If you are still thinking this sounds too simple to be real, consider who else reached the same conclusion. NASA. In the 1960s, when engineers prepared for the Apollo moon missions, they faced an impossible constraint. How do you provide safe drinking water inside a tiny capsule floating through the vacuum of space? You cannot haul heavy filtration systems, you cannot waste energy boiling water, and you absolutely cannot use corrosive chlorine gas in a sealed, pressurized cabin where astronauts breathe recycled air. Every solution had to earn its weight in ounces, and most of them lost. NASA's solution was an electrolytic silver-copper ion generator. It was about the size of a cigarette pack. It weighed roughly 9 ounces. It required almost zero power. This device dispensed metallic ions directly into the water supply, successfully eliminating bacteria and preventing algae growth, all without leaving any chemical taste behind. When that Apollo technology was eventually declassified, it found commercial applications on Earth. Cooling towers, public fountains, aquarium systems, aquatic habitats at marine research centers, even military field units that needed clean water without heavy logistics. And the Environmental Protection Agency went further, officially registering hundreds of copper alloys as antimicrobial materials capable of killing bacteria on contact. That registration is not a rumor. It is a public document. You can look it up yourself. Think about what all of this means. The most demanding water quality program in human history, with astronauts' lives and a national reputation on the line, chose electrochemistry over cartridges. They chose it because it was compact, reliable, and weightless in every sense that mattered. If that principle was good enough for the moon, it deserves at least a second look here on Earth. Now let me pause there and let you feel the weight of that 4,000 years of human observation, peer-reviewed electrochemistry, NASA field testing, EPA verification. The evidence does not whisper, it shouts. And yet, if you walk into any camping store today, the shelf is stacked with $40 pump filters and $90 bottles, while a few dollars of metal from a hardware store can accomplish similar results for certain contaminants. There is a word for that kind of gap between truth and commerce, and it is not conspiracy. It is incentive. So why have you never heard of this? That is the question that keeps me up at night, and I want you to really sit with it. The answer is not a conspiracy, it is a business model. The global water purifier market is valued at over $35 billion per year. The profit engine of this industry is not the device, it is the replacement cartridge. Activated carbon filters saturate and expire every 2 to 6 months. You buy the pitcher once, and then you buy cartridges forever. It is, in effect, a subscription model built around a physical product. The company that designs the pitcher knows exactly how many cartridges you will need this year, next year, and for the rest of your life. That is not an accident of engineering. That is revenue planning. Every single time you change that cartridge, a company gets paid, and the easier it is to forget the cartridge, the more often you change it. That is exactly how it is designed. Now consider what copper-zinc technology represents to this model. A KDF-based filter removes chlorine, captures heavy metals, and inhibits bacterial growth. It requires no electricity and no chemical regeneration, and it can remain effective for up to 6 years. Do the math on that. 6 years of purification from one purchase versus 12 cartridges in the same window. You cannot build a recurring revenue empire on a product that does not need replacing. That is the entire story in one sentence. To be fair, this does not mean the industry has suppressed the technology in some smoky backroom. Copper-zinc media does appear in some commercial filters, but it is almost always a minor supplementary component, never the primary filtration stage. The emphasis remains on carbon cartridges that need regular replacement, because that is where the profit margin lives. It is not villainy, it is economics. Nobody at those companies wakes up evil. They just wake up to a spreadsheet that rewards the same answer every quarter. But the result for consumers is the same. The simplest, most durable option stays in the background, while the most profitable option takes center stage. You're not being lied to. You're being outmarketed. So, now, the part where this video actually pays for itself. Everything we have discussed, the history, the chemistry, the space program, means nothing if you cannot use it. But first, an honest disclaimer. Because anyone who sells you a single solution for everything is selling you a lie. Copper and zinc galvanic cells are highly effective against bacteria, chlorine, and dissolved heavy metals. They are not effective against everything. Specifically, they do not remove agricultural pesticides, and they cannot reliably eliminate parasitic cysts like Giardia and Cryptosporidium, which have hard shells that resist electrochemical attack. Contact time matters too. A quick dip is not treatment. These reactions need hours to do their work, which is why 4 hours is the practical minimum, and overnight is best. This is not a flaw in the technology. It is a boundary, and knowing the boundary is what separates a survivor from a victim. The people who die in survival situations are rarely the ones who know too little. They are the ones who overestimate what they know and skip the steps that would have saved them. Now here is how you build a multi-step system that covers those gaps, using parts you can find at a hardware store, a garden center, and a campfire. First, if your water source is visibly murky, pour it through a cloth, a bandana, or a tightly woven t-shirt. This removes sediment, floating debris, and larger particles. It does not purify anything. It just prepares the water for the real work, so the metals are not wasting their energy on mud. Think of it as clearing the table before cooking dinner. Second, the heart of the system. Go to any hardware store and buy a length of bare solid copper wire, about 14 gauge, and a strip of pure zinc metal. Total cost, under $5. One warning here. Make sure the copper is bare, not enamel coated, and make sure the zinc is pure metal, not galvanized steel, which has a different surface chemistry. If you cannot find pure zinc at the store, some people use zinc anodes sold for boat or water heater protection. Just rinse them well first. Cut both to equal lengths, roughly 12 inches or 30 centimeters. Now twist them tightly together. This direct metal-to-metal contact is critical. Without it, there's no electron flow and no galvanic reaction. Loose contact means a weak current, and a weak current means half results. Drop the twisted pair into your water container. A canteen, a pot, a bottle, any non-reactive vessel works. Then wait. 4 hours is the minimum effective time. 8 hours is significantly better. Overnight, 16 hours is ideal. While you sleep, the galvanic current is working silently. Zinc atoms releasing electrons, chlorine molecules being neutralized, heavy metal ions being pulled from solution and bonded to the metal surface, bacterial cell walls being destroyed. When you remove the metals in the morning, rinse them, dry them, and they are reusable for months. How will you know when the metals are finally spent? The signs are easy to read. The surface starts to look dull and crusty, covered in scale and oxidation, and the water no longer gains that faint metallic crispness it had the first few times. That is your cue to sand the surfaces gently, or simply replace them. $1 of copper and a few dollars of zinc should cover a very long season of clean water. Third, carbon, but not the kind from a store. Take charcoal from your campfire. Not briquettes, which contain chemical additives, but natural hardwood charcoal, the kind that crumbles into honest black chunks. Crush it into small pieces and pack it into a clean container with a small drainage hole. A sock, a cut plastic bottle, or a piece of bamboo works perfectly. Pour your metal-treated water through this charcoal layer. The charcoal absorbs organic chemicals, pesticides, and residual tastes that the galvanic cell does not target. This is the step that fills the pesticide gap I mentioned, and it is also the step that makes the water actually taste like water. Fourth, a natural sieve you have probably never heard of. Diatomaceous earth is a soft white powder made from the fossilized remains of ancient microscopic algae called diatoms. Under magnification, each particle looks like a jagged porous sponge, which is exactly why it works. When water passes through a layer of diatomaceous earth, particles as small as 1 to 2 microns are physically trapped, including giardia and cryptosporidium cysts, which are too tough for chemical treatment but too large to pass through this natural sieve. Diatomaceous earth is available at garden supply stores, and it costs very little. One caution: look for food grade or filter grade diatomaceous earth, not the pool grade kind, which is treated differently and should not touch drinking water. The result? By combining these 4 steps, cloth prefiltration, copper-zinc galvanic purification, charcoal chemical absorption, and diatomaceous earth physical filtration, you have constructed a multi-stage water purification system from hardware store metal, campfire ash, and natural mineral powder. It addresses bacteria, chlorine, heavy metals, organic chemicals, pesticides, and parasites. It costs under $10 total. It requires no electricity, no batteries, and no replacement cartridges. And the core metals are reusable for months. That is the entire system, and it is older than the pyramids. Now, before the ending, I want to be honest with you about something personal. I have spent a lot of hours researching this topic, and the more I dig, the more I realize that the world is full of forgotten knowledge that could change how we live. This is not about hating companies or refusing to buy filters. Modern filters save lives, and I'm not telling you to throw yours away. I am telling you that knowledge is the real survival tool. The filter you buy expires. The understanding of how to build one with scrap metal does not, and that is a difference you can carry in your pocket for the rest of your life, whether you ever need it or not. Let me tell you something I do not usually share. When I first found this story, I assumed the interesting part was the chemistry. It was not. The interesting part is that humans keep forgetting what we already learned. We built empires on copper. We flew to the moon on copper and silver. And then we forgot, because forgetting is profitable. So every once in a while, I go back to the hardware store, buy $6 of metal, and remind myself that the most advanced survival tool is not always the most complex one. If that resonates with you, subscribe. Not because I need the number, but because I want to keep making videos for people who think this way. And tell me in the comments what other ancient technology we should dig into next. I read every single comment, and the best ones become videos. 4,000 years ago, an Egyptian healer poured river water into a copper vessel and waited. In 1984, a researcher dipped a brass pen into chlorinated water and watched the chlorine vanish. In the 1960s, NASA engineers built a 9-ounce device using the same principle and sent it to the moon. The thread connecting these moments is not technology. It is attention. Someone in each era paid close enough attention to the natural world to notice what the Earth was already doing, and that attention saved lives, and then it was lost, and then it was found again. Copper and zinc do not care about patents, subscriptions, or marketing budgets. They simply do what their atomic structure dictates: release electrons, generate current, and make water hostile to contamination. The most advanced survival tool is not always the most complex one. Sometimes it is 2 metals twisted together in a canteen doing their quiet work while you sleep. The Earth already solved this problem. We just forgot to listen. If this video changed how you think about water even a little, do me one final favor. Share it with someone who values self-reliance, someone who would want to know this before they need it. That is the whole point of this channel. Putting knowledge back into your hands before the world makes you need it. Question everything. Never stop digging. And I will see you in the next one.